everyone, it's Alyssa and welcome to You Can Learn Math. Today is about multiplying binomials. Big question here. What is a binomial? That would be a good first question to answer, I think. A binomial usually looks something like this. It is two terms and we can't combine them. When I say, what do you mean you can't combine them? Well, let's say if it was 3 plus 3, I could combine those. If it was 2x plus 3x, I could combine those. Those can be combined. This can't. I can't add those together. They don't match. They don't have the same variables with them, the same level of variable, talking about exponents. I can't do it. So a binomial, it can't be combined. It's in the smallest it can get. Now what happens if we want to multiply two binomials together? Well, in the previous video that I did on the distributive property, link is in the description below. It's a weird looking arrow, but anyway, it's supposed to be an arrow pointing to the description below. In the previous one, we did things like this. This was mentioned. This would be called a monomial. Mono is the prefix that means one. And this is a binomial, prefix meaning two. 1, 2. Okay, in that example, just as a quick refresher, we would multiply individually by the two terms, is the word for it, inside the binomial. I know we're using a lot of terms, but these are the terms you're going to see in your math book, so I want you to be familiar with them. So in this, we do 5 times x first. That's 5x. That's that right there. And then 5 times 2 is 10. And we've multiplied the monomial by the binomial. So what if it's two binomials? What if it's something like this? Okay, well now what? When it was just one monomial, I could just go boop, 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 and all right, I've got my answer. But now I've got this extra thing stuck on the end here. What am I supposed to do with that? Well, what you do is pretty much the same thing we did with, you treat each of these like their own little monomial and you multiply. So I would do that, and I would also do this. You just pretend they're both out there by themselves and multiply them through. So let's do that. Okay, first start with our x and we're going to multiply it by the first one there is x. X times x is x squared. Then I multiply by the second one. X times positive 6 is positive 6x. And now go to the 3. I'm going to go under so it doesn't get confusing. 3 times x is 3x. 3 times positive 6 is positive 18. Okay, so I've multiplied. The next step then is, can we combine any of these things? Remember to combine it. And then another video, combining like terms, if you'd like more explanation, again, in the description below. If we look at these, the ones we can combine would be if we have numbers that are by themselves, we can combine those. And if we have terms that have variables that have the same exponent. So here we have x to the power of nothing. There's nothing there. X to the power of nothing visible. It's actually x to the power of 1, but you know, we don't see an exponent. Don't get me on a technicality here. Yes, it's technically 1, but you know what I mean. We don't see any exponent there. So those are the same. We have 6x and 3x. So we can combine those. 6x plus 3x is 9x. The other two terms we can't combine, and that's it. We've multiplied it. And you know what this means is we could actually put real numbers in here and this would be true. So watch, let's say if I put in 2 for the value of x. Okay. So let's say 2 plus 3, let's just do it like we normally would do it. 2 plus 3 is 5. 2 plus 6 is 8. 5 times 8 is 40. All right, well, let's look and see if, if this works. Okay, so 2 is x. 2 squared plus 9 times 2 plus 18. 2 squared is 4. 9 times 2 is 18 plus 18. 4 plus 18 is 22. 22 plus 18 is 40. There you go. There's your proof. And any number this would work with. I just picked 2, but any number this will work with. Okay, so it does work. Now there's a little shorthand if you want to make sure you've multiplied everything correctly. For some students, doing something, just visualizing it as saying, okay, I take this first one and I multiply it by both, and then I take the second term and multiply it by both. And that, that works for them. Another way to look at it, which you will see this a lot in your books, is called FOIL. I'm going to throw a negative in here. FOIL. FOIL stands for first, outside. I've written that too big. Inside. Last. So this means we multiply the first terms together. We multiply the outside terms. We multiply the the inside terms. Actually, usually write it like this: the inside terms, and then the last terms. The reason a lot of teachers draw it like this, the way I just did, is because it makes a happy face, because here's the smile. And there's his chin, there's his ears, and there's the eyebrows. You see the face? I've seen a lot of teachers do that to make, oh, look, it looks like a face. It's the same thing. It's the same as what I've just done. You can also choose to draw it in a way that's very similar to what we just did. So, for example, you could say first, outside, inside, last. I haven't done anything different. I just drew the arrows differently, top and bottom, to make it look like a face. A lot of teachers like making it look like a face. But if I draw it like this, you can see it's exactly the same as what we just did, of saying, oh, I have to take this first term and multiply it by both of them. Then I take the second term and multiply it by both of them. Okay, so if your teacher wants you to do the first, outside, inside, last, it doesn't, just stay where I tell you to stay, computer. All right, our first terms, this meaning the first in each binomial, x times x would be x squared. Our outside, meaning the ones on the outside of these binomials, 6, negative 6, and x. Multiply those together, we get negative 6x. Then our inside terms, the ones in the middle, positive 2 times x. And then finally our last terms, 2 times negative 6. Okay, can I combine any like terms? Yes. These here in the middle, both are just plain x's without any fancy extra exponents. So negative 6 and x and 2x, add those together, negative 4x. The others just drop down because I can't do anything with them. Okay, do one last example. going to do it. I'm just thinking in my head here. Okay. Where else would I be thinking? I'm thinking in my pinky finger. If I have something like this. Okay, add some negatives and some coefficients. Nothing has changed. We're still going to do the same process. So I'm going to take this first one and multiply it there. 2x times negative 3x is negative 6x squared. Remember, I multiplied the two numbers, 2 times negative 3, and then I multiply the variables, x times x, negative 6x squared. Okay? Then 2x times negative 2, that's negative 4x. Then on to my second, negative 5. Make sure when you are doing this that you keep that negative with it. If there's a negative before it, keep it with that number. You don't look at it as just a 5. No, this is a negative 5. Very important. So negative 5 times negative 3x is a positive 15x. Negative 5 times negative 3 is positive 15. If you need a review on multiplying negatives, also video, link in the description below. And finally, negative 5 times negative 2 is a positive 10. Is there anything I can combine? Yes, these in the center. Are you noticing a trend? Yes. When you have the binomials where they both have the same, it's like x and x squared, what have you, if they're the same, you're going to be able to combine the two middle terms. In those cases, it's a pattern. Okay, negative 4x plus 15x is 11x. The others don't have anything. And that's it. All right, so that is our multiplying binomials. If you need help with multiplying trinomials, that's in another video, link in the description below. And that's going to be it for today. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.